This is GD&T Chapter 3. As we talked about before, you should have your objectives for Chapter 3 ahead of you. Here are the objectives. In this unit, please pay attention to the terms in objective number 6 as you follow through this presentation. Okay, location. A lot of this chapter is going to be a review for you. So all dimensions control size or location of features. Now most features will require 1 or 2 location dimensions. Location and size must be controlled in all 3 axes. That's why we have multi-view drawings. This is an example of sizes and location. So S's are for size and L's are for location. S1 is the overall length of the part, L1 is the location of the slot, etc., etc. Now these are the type of lines we use for dimensioning. So extension lines extend features, whereas dimension lines show the direction and magnitude of a dimension. And then leader lines or leaders connect information to a specific feature on a part. So here we have some examples of what a dimension line is and what a leader line is, and some of the conventions. Okay, now here's a term, unidirectional dimensions. I prefer unidirectional dimensions. So in a unidirectional dimension scheme, all of the dimensions, like as shown here, all of these dimensions are shown in the horizontal. And it's readable from the bottom of the page. And this is what we use in Y14.5. Now line dimensions, on the other hand, the dimension is shown parallel to the dimension line. See how this is rotated 90 degrees here. So horizontal dimensions are readable from the bottom of the page, and then vertical dimensions are readable from the right side of the page. We're not going to use that in Y14.5. Now the measurement systems we use are either the U.S. customary system, in case we're using inches. That's what we use in the United States quite extensively. Or the SI system, that is metric units. The main unit is the millimeter, and then a lot of countries outside the US use SI. Then there's always notes. Okay, so you don't have to really say, you have to say what dimensions are being used, what measurement system is being used. So unless otherwise specified, all dimensions are in millimeters. So that tells the person reading the drawing that what the system, measurement system being used is. Okay, so decimal inches. You can have tenths, hundredths, thousandths, or smaller if your tolerances are really tight. You don't use a preceding 0 for values less than 1. And tolerance requirements may be affected by decimal place when the title block tolerance. That's the block tolerance. So for example of block tolerance, you'll see this on a drawing right here. So if you display a dimension to 2 decimal places, it is assumed that the block tolerance is plus or minus 20 thousandths. I read that as 20 thousandths. If you display a dimension to 3 decimal places on the drawing, then that tolerance is plus or minus 10 thousandths. So that's otherwise known as block tolerances. Now, when you're using metric units, you use decimals, you use whole numbers. You don't need the abbreviation millimeters, okay, because you have the drawing note that said, hey, all dimensions are in millimeters. Now, when you're using the metric system, preceding zeros are included for values less than 1. That's the difference between the metric system and the U.S. customary system on drawings. You need to use preceding zeros with millimeter units. And then accuracy may be affected by decimal places if a title block tolerance is used. Okay, here's another term, chain dimensioning. Chain dimensioning is a simple system in which all features are located from adjacent features. This has the disadvantage of accumulation of tolerances. Here's an example of chain dimensioning. Okay, for instance, we have this width 1.25, and then we have another width, and then another width, and another width. So Okay, what happens here is you have these dimensions coming off of each other. Okay, those are chain dimensions. So in which case what we have is an accumulation of tolerance. Okay, and this thing shows you what the effect of that is. Another dimensioning system would be the rectangular coordinate dimensioning system. That's a system where three mutually perpendicular planes establish the coordinate system. It helps to reduce the effects of tolerance accumulations. And in the rectangular coordinate dimensioning system, you really have three methods. One would be baseline dimensioning. The other one would be rectangular coordinate dimensioning without dimension lines. And then tabular dimensions. Let's talk about each one of those. This is the case of baseline dimensioning. Okay, all dimensions are coming from a baseline. So in this particular part, we have this edge right here, and then we have this edge right here, and then all the dimensions are coming off of that edge. Okay, so the 1.25, the 3.25, the 4.25, those are all coming from that edge. So that is known as the baseline dimensioning system. Now, differentiate between that and the rectangular coordinate without dimension lines. Okay, so what we have here is we have a 0, 0 coordinate system here. So the 0 in the y direction, 0 in the x direction, and then these dimensions here are all based on those 0 points. Okay, so these are without dimensioning lines. And then another dimensioning system here would be the polar coordinate system, in which case features are located and defined by a distance from a center point and then the angle. Okay, so for instance, these two holes here are located by angles with respect to 0 degrees, and then the radius from the center point. That's called a polar coordinate system. I'm going to stop right here to keep this video short. Thank you.